Okay, so this is me working out the review you guys did in class for anybody who had any questions. So most of this is just vocab. Maybe I can explain a little bit of it to you. The key things would be, first of all, looking at what you're even trying to find. These two are single letters. That makes them points. So our only options for points are the center point of a circle or point of tangency. Now, some people struggle with point of tangency. If you don't know what that is, just know that it's not in the center of the circle. Tomorrow's test will be multiple choice or matching. So, only one of them will be center and one would be point of tangency. So it's pretty easy to find. So of these options, you have C and you have F. Well, C is obviously the center, so that makes this one the point of tangency. But I will tell you, hopefully you have your glossary. If not, you can look it up on my website. Oh man. Let's just undo that because I don't want to write that again. Let me make this smaller. So a point of tangency is where a tangent line meets the circle. So by definition, the tangent line intersects the circle at just one point. So that point is the point of tangency. So this line right here is a tangent line because it intersects this circle just right here at point F. So let's see if FE, line FE, is a choice. It's right there, so that is a tangent line. We also have FE being tangent to this circle at point E. That's a point of tangency, but that's not a choice. AG, line AG, that is a tangent line. It has a point of tangency right there and right there. So if it had point A or point G, those would also be points of tangency. So let's see if AG, line AG, is right there. That is a tangent line as well. Okay, so what's up next? HG. Now this is a segment. See the difference in that and that? That's a line, that's a segment. A tangent line will always be a line. A segment could be a radius, could be a diameter, or it could be just a chord. So HG is right here. That is a radius. By definition, a radius goes from the center to a side. So HF would also be a radius, but that's not an option. CB would be a radius, CA would be a radius, and CE would be a radius. So I don't think there are any more radii. All right, this is a segment, DB. So if it's not a diameter and it's not a radius, it's just a chord. If this were like this, it would be a completely different answer, like this one right here. But a chord, by definition, has its endpoints on the circle. So that is just a segment that stops right there, which makes it a chord. If it keeps going, meaning it's a line, then it is a secant, because a secant is a line that intersects the circle in 2 points. So it intersects it in those 2 points. Now, BE is a segment, but because it goes through the center point, it's not just a chord, it's a diameter. There won't be this many questions on the test. It'll be matching, and I think there's maybe 8. Yes, there's 8. So, and each one's just used one time. So then our other options for these are major arc, minor arc, and semicircle. So minor arc is less than half the circle, major arc is more than half the circle, and a semicircle is exactly half the circle. So AEB, arc AEB, starts at A, goes to E, and ends at B. So that's like this entire arc. I'm terrible at tracing it, but that whole thing. That is definitely more than half the circle, so we call that a major arc. Okay, then we have FG, which if it's got 2 letters, it's got to be a minor arc, because you can't name a major arc with 2 letters. So that right there, F to G is less than half the circle. It's a minor arc. Then we have B to D to E, which makes up half the circle, which makes it a semicircle. So that's vocab you need to know in your head by tomorrow. You won't have any repetitive ones. And actually, I'm looking at the test right now. Point of tangency is not even an option, and neither is center. So if you want to listen to this, your options are going to be chord, diameter, radius, secant, tangent, minor arc, major arc, and semicircle. And that's it. So let me... Okay. So number 12, this problem is a Pythagorean theorem problem, and you'll have one like this on the test tomorrow. You'll have 2 that are Pythagorean theorem, but one will be simple Pythagorean theorem. This one's kind of challenging because you don't know either of these radii. And on the test, I feel like it'll be a little easier for the other one. So when we do Pythagorean theorem, it's leg squared. So it's like a squared plus b squared. So that leg squared plus this other leg squared. And most people mess that up because they feel like 36 should be the other leg. Well, it's not. It's 48 because the hypotenuse is this entire thing. And to get the whole thing, you have to add those together. So you get 36 plus x for the entire hypotenuse. So this equals 36 plus x, all squared. Now, this has become difficult because of the algebra. So you've got 2 options. You can do like 36 plus x times 36 plus x and FOIL it. Or you can do like the box method. Looks kind of like this. Sorry. And you do the 36. Sorry, that's a bad 3. My pen's messing up. 36 plus x. I'm not going to do this way anyway. I'm just showing you. So hopefully you remember what that is. I don't really like to do the box method. Foiling is just double distribution. So you do this number times each one of these numbers. So 36 times 36 is 1296. Plus 36 times x is 36x. Then we do the x times each one of these. So x times 36 is 36x, and x times x is x squared. Now you can put these together, get 1296 plus 72x plus x squared. Now, that's just one side of our equation. So up here we still have x squared on this side. 48 I'm actually going to go ahead and square. You get 2304. And that equals 1296 plus 72x plus, plus x squared. Now there is a trick I taught you guys where you can square this first number to get this, square the second number to get this, and to get the middle number you just multiply these together and double it. And it'll be that one every time. So 36 times x times 2 would be 72x. But for some reason this year, not everybody's been wanting to do that. So I kind of haven't mentioned it much. So the first thing to do to solve this would be to subtract x squared from both sides. It'll cancel out so nicely. Then I would subtract the 1296. I don't know what's going on with this pen. So 2304 minus 1296 is 1008. That equals 72x. Then you'll divide both sides by 72. 1008 divided by 72 is 14. So you get 14 for x. Oh, that is a tough problem. I think it's worth 5 points tomorrow on your test, but like just setting this up is worth a point, and foiling correctly is worth a point. I mean, just do as much as you can. I think you can do that if you really study and learn how to do it, but this is where most people will mess up, and that is just straight algebra skills that you will need next year for Algebra 2. So it's good practice. Okay, now one thing I am letting you use on your test is these circle notes. They are on my website. You can print them off. You have to have your own copy. You cannot use anyone else's. So if you don't have them, you better print them. So arcs and angles is what we're dealing with if we're dealing with degree measures. If you're dealing with segment lengths, it's going to be one of these. So let's see. These have degrees on them. So that's going to be that middle column. And then we have to decide where these are intersecting, which they're intersecting right here in the inside the circle. So degree measures inside the circle. Now it wasn't in the center, so the two lines intersect inside the circle but not in the center. So what you do to get the angle is you add your two arcs and divide by 2. See how helpful that is? If you have it. So we add the two arcs that we have, 140 plus 146 divided by 2 equals our angle, which is x. Now I think on our page it had the x over here. It shouldn't matter. But if it confuses you, you can do it the other way. So if I add 140 plus 146, I get 286. And I would do that in separate steps before I divide by 2, because otherwise, my word, sorry. This is just writing all the time when I don't want it to. Oh, my word. Sorry, otherwise you need parentheses around that. And so if I actually divide that by 2, I get 143. For x, and that's what you should have gotten. Remember, you can always pause the video if you need to see it or rewind it. I don't know what this pen is doing. Okay, so on this one, this was from the lesson we did on chords. Now, all these notes are on my website, but you can't use the chord notes on your test tomorrow, so you need to know those. So there's a lesson over chords that had a rule that said if the chords are equidistant from the center, which they are because those are congruent, then the chords themselves would be congruent. So you just set them equal. So x plus 9 equals 3x minus 11. I'd subtract x from both sides. You get 9 equals 2x minus 11. Add 11. You get 20 for 2x. Divide both sides by 2. And you get 10. Again, pause it if you need more time with that. Okay, this was in the tangents unit. I called this the ice cream cone theorem, and I said no one wants to eat an uneven ice cream cone. So if you have these two tangent lines out here, they should be congruent. So x plus 8 equals 5x minus 4. Subtract the x. You get 8 equals 4x minus 4. Add the 4. You get 12 equals 4x. Divide by 4. And you get 3 for x. Okay, now this one is one that you will find on those circle notes. So degree measures, so arcs and angles, that's the middle column, and they lines are intersecting outside the circle. So let's go to that. We're in the middle, arcs and angles. Outside the circle, you do the measure of the angle equals the arc minus the arc divided by 2. So we always put the big arc first because you're not going to get a negative angle. So big arc minus small arc divided by 2. So the big arc is x minus the small arc is 56 divided by 2. And since it has it that way on the notes, I'll put the angle over here. Should equal the angle. So to solve that, you can do this a couple different ways. A lot of people just like putting that over 1 and then cross multiplying. That's actually what I prefer to do. But the way we've been doing it in class is multiplying both sides by 2 and canceling the 2 out there. So 29 times 2 is 58. And then you get x minus 56. Then you add the 56. You don't multiply the 2 here because it completely cancels out here. I had a lot of people that were doing that today. So 58 plus 56 is 114. So you should get 114 for x. All right, these are talking about segments in the circle. They are intersecting not in the center, and they are not degree measures. So that's segment lengths, intersecting inside the circle but not in the center. So we're doing part times part equals part times part. A lot of people were doing this but adding the parts. You should be multiplying. So on this line right here, the two parts that you're multiplying together are 3x and 2x. So you multiply those together, just like that. Then you have 3 times 18. Now a lot of people, again, we're putting 5x or 6x on this. When I multiply those together, I get 6x squared. And when I do 18 times 3, I get 54. So then I would divide both sides by 6. Get x squared equals 9. Take the square root of both sides, and x equals 3. Okay, well, there was one like this on the 5-chance review we did. Most people did well with that. So we've got vertical angles here, so that's got to be 70 because those would be the same, 70 degrees. Then this is this is a straight line, so these should add up to 180. It's also a half circle, which adds up to 180. So I would add 70 and 50 and get 120 and subtract that from 180 and get 60 degrees for this one. Then these two make a half circle, so you can do 180 minus 70 and get 110 for this angle. Now because these are in the center of the circle, then the angle equals the arc. So if this angle is 70, this arc right here is 70. So measure of arc AB is 70. Now on your test, you will have to say if that's a major arc, minor arc, or semicircle. So less than 180, that would make that a minor arc. BC is 110. That is a minor arc. I have a lot of people mess that up because they have the number 100 in their head, and since that's bigger than 100, they put major, but that is minor because the number should be 180. Now A to B to C, you would add the 70 and the 110 and get 180. That would be a semicircle. AE is 60 degrees. C to D to E would add 70 and 50 and get 120 degrees. That is a minor arc. Then B to D to C. So you could add up all these, or you, since it just doesn't include this one, you could do 360 minus 110 and get 250. You should get the same answer either way. And that is a major arc because it's more than 180. Now this was from that unit about chords, or the section. Said if you had two congruent chords, which those are congruent, then these are congruent. Now, we can call them both x, and x plus 118 should add up to 360. So then I would subtract this 118. So 360 minus 118 is 242. And I would go ahead and combine those x's and get 2x. Then divide both sides by 2. Now people tell me all the time, can't we just subtract 118 from 360 and divide by 2? And yes, that's exactly what I did. It's just that I wrote it out algebraically and that scares some people. But don't worry about it. So AC is x, so AC, measure of AC is 121 degrees. This one's pretty easy. If these chords are the same, then these arcs are the same. I guess I should put 2 lines. So this is 52. So then from Q to R to S, you would just add those together and get 104. Now this one is one that seems to be confusing some people. Let's highlight this. So, well, that's not enough of a highlight. So if I extend this angle right here, this 113, is creating this arc. Now these two lines are intersecting on the circle, so the angle is the arc divided by 2, or the arc is the angle times 2. So we have the arc, or no, I'm sorry, we have the angle. So we would want to multiply that by 2 to get the arc. So 113 times 2 should get us this blue arc. So that is 226. Now PRQ, that is the one it's asking for, so we'll call that the answer. On this one, it's the same situation. Oh, I can't trace that. But this angle right here is creating this arc if you extend those lines. So we do 80 times 2 to get this arc is 160. It's actually asking for this angle. But since that angle goes to the same arc, it would be half of that. So x actually equals 80. That's a 2-step problem. On the test, it will just be a 1-step problem and be much easier like this one. The review's always more difficult than the test. Okay, on this one, we have opposite angles adding to 180. That's just a theorem we learned that you just got to remember. So for 28, it was find x. So 4x plus 5x equals 180. And then for 29, it was find y. So 11y plus 7y equals 180. Now on the test tomorrow, a lot of people will set them equal, and they'll get crazy decimals, which should be a red flag because usually we don't put crazy decimals. But they can happen. So divide by 9 and x equals 20. Then we have 18y, sorry, equals 180. Divide by 18 and y equals 10. And if you want to check your answer, you can plug in 20 for x in those, plug 10 in for y. So your angles are 110 and 70. Those add to 180. And then for the x's, 4 times 20 is 80, and that's 100. So opposite ones should be adding to 180, and then they all 4 should add to 360, which they do. It's a great way to check your answer. Now these last ones, the only thing I worry about on the test is that you have to know the formula, which is x minus h all squared plus y minus k all squared, and that equals the radius squared. And HK is your center and R is your radius. So our center of this one is 0, 0, which means when you do x minus 0, you're just going to get x. So it would look something like this, where you just have x squared. So we know it's neither of those. Then y is also 0, because this is our center. So you should be able to eliminate a, because it's going to look like this. Then your radius is 1, 2, 3, 4, 5. So you do 5 squared and get 25. I know we could have gotten b a second ago, but I just want to explain that. But tomorrow it won't be multiple choice. You'll have to write that out. So make sure you know how to get that. Now on this one, if you don't know the center, I would count 1, 2, 3, 4, 5, 6, 7, 8. So the diameter is 8. So halfway would be 4. So your center is -1, 0. And your radius is 4. So when you plug in the radius to this equation, you square it. So it should be 16. So you can mark through that one, because it's got to be one of these. Then it should be x minus -1 squared, which becomes x plus 1. So you can eliminate that one. Then it's y minus 0, which is just y squared. So it should be that one. Again, you've got to memorize this formula. So if we have the center, I'm going to ignore my answers and just write it out. You have x minus -3, which becomes x plus 3 squared, plus y minus -14, which becomes y plus 14 squared. And that equals 4 squared, which is 16. So mark out that one because it doesn't equal 16. Plus 3 plus 14. There you go. You should be able to eliminate these right off the bat that don't even have that number. I mean, that's not even the right number for the problem. And then the last one, you just pull the center out and the radius out. That means r squared is 25. So if you take the square root, r is just 5. So you can eliminate this one. And then it's supposed to be minus. So if it is minus, then you're dealing with positive numbers. So it's kind of the opposite of this sign. So it should be +9, +12. So it should be that one. And that's it.